Thank you for having me here, and thanks everyone for taking time out today to listen to what we have to say here. A brief introduction about myself. My name is Bharat Krishnamurthy. I'm the CTO at Yubi, primarily a Java and C developer. I still try to stay true to that, although it's getting more difficult every day. I started my career many years ago working on operating systems at Los Alamos Labs, operating systems that ran large clusters. Moved to IBM Research, worked on distributed systems that ran in telcos in India. Moved to life insurance. I don't know why, but just decided one day that I wanted a change of scene. Then that took me to Paytm, where I managed systems that managed wealth management, insurance, and the entire financial services portfolio. And for the last 3.5 years, I've been at Yubi, and along with my team, building India's largest debt marketplace. Primary interests are in operating systems, high-performance computing, distributed systems, and as a part of my role, I interact a lot with some of our biggest customers who happen to be the largest banks in the country and some of the largest fintechs in India, Middle East, North Africa, and Southeast Asia, and hopefully in the US by the end of this year as well. So who are we at Yubi? There's a good chance that a lot of you might not have heard of us in the past because we largely work behind the scenes. We are not a B2C organization. We are largely B2B. And we have products and solutions that cut across the entire credit lifecycle. We have products that start from loan origination, transaction processing, loan management, underwriting, collections, monitoring. And across this entire stack, we obviously have AI embedded and agents embedded across the tech stack as well. Just to give you a few indicators on the scale of our business, last year, we did about $5 billion worth of loans were processed on our platform. In Indian rupees, that turns out to about 42,000 crores. We received close to about 150,000 as of today loan applications coming to our platform per day, and we disburse about 87 to 100,000 loans every day. The P99 performance that we commit to many of our customers is about 9 seconds. So from the time that the loan application hits our platform till that the money is disbursed into the customer's account happens in under 9 seconds, and with some customers it's actually in about 2.5 seconds. We work across 15 different asset classes. I'll touch a little bit more upon that in the following slides. We have about 56 lenders on our platform and over 100 originators as well. Now, this is a small subset of our customers, just to give you an indication of the diversity of our customer base. Some of our customers over here have about 600 million monthly active customers, right? And needless to say, the names that you see at the bottom, they are the largest payment aggregators in the country. We have banks in the Middle East who deal with a really large customer base across multiple countries in the Middle East. And our platforms run everything from cattle loans to tractor loans to, it could be a farmer looking to buy a tractor in rural India. Their loans go through our platform. It could be a customer using a GPay app who's looking at getting a personal loan for, let's say, the holiday season. That loan goes through our platform. And what this should probably give you a sense of is the enormity of the complexity of what we do, right? Before I go to the technical architecture, a little while back, Spencer was talking about the demands of resiliency and regulations. If you look at the customers in this slide, each one of them almost all of them are a regulated entity, right? They're all regulated entities, which means that they go through audits practically every month. Either the Reserve Bank or SEBI, someone is kind of putting them through an audit practically every month or every other month. Now, what that translates to us is that we are practically going through an audit every other day. So if something goes wrong with the data in our platform, I have to be personally in front of an audit committee answering why something went wrong, right? So we don't take our job lightly. We understand the gravity of what we do, and we understand the value that we provide to our customers. So that leads us to how we treat our data as well. A few attributes of our technology. We largely operate in a multi-tenant cloud on AWS. We also operate on AWS, Google Cloud, Oracle Cloud, and Azure. So if a customer wants a single tenant instance of our software, we deploy it and we run it. We also run on-premise on bare metal servers in some data centers of certain banks. We operate in the India region, we operate in the Middle East, we operate in Saudi Arabia, Southeast Asia as well. And we operate at a very high scale. For example, our collections platform triggers about 1 billion customer interactions per month. This means SMS sent to customers, email sent to customers, feet on street meeting customers, bot calls made out to customers. It's about 1 billion a month. Yeah, that's a really large scale. And we were looking at our current databases, we're touching about 120K IOPS. So our need for a really sturdy, reliable database was really significant. Now, to give you a sense of what we do, right? This might not really, everything that I described so far might not really give you a picture of what we do. For the audience here, I think the easiest way to kind of think of what we do is look at UPI, but for lending. Right? And that's what we aspire to be, and that's what we do. So we are a network. We integrate with all our partners, all the partners that you saw in the few slides before. We integrate with them. We integrate with their core banking system, with their loan management systems, loan origination systems, in many cases even HRMS systems, anti-money laundering systems. And we kind of broker and manage the end-to-end transactions that flow through our platform. The difference between UPI and us is that UPI has insane scale, right? I'm not taking that away. It's insane scale. But the complexity of every transaction is relatively simple. There's a debit on one side, there's a credit on the other side. Compared to that, a loan transaction involves hundreds, maybe even upwards of 1,000 different data fields. Something like a housing loan could have father's name, mother's name, your postal address, your work address, geolocation of the property that you want to buy, and so on, right? So the complexity is significantly high, and the requirement for a SQL database is also very critical. One other key aspect of what we do, which really adds to the scale, is every new lender or originator or any customer who comes to our platform is not just one customer for us. They bring with them anywhere from tens to hundreds of thousands of borrowers onto our platform. So the scale that we see on our platform is not exactly linear, but with every customer that we add, it kind of goes up by a step function significantly, right? So that's the kind of scale that we really have to manage. And the systems that we build and that we run aren't just transactional platforms, but for many of our customers end up being systems of record, which means that our customers look at the data as belonging to them, right? It's their data that is sitting in our platform, which means I need to give them the required level of control, protection of the data, but also ensure that they get the ownership of the data, which means I need to enable them to bring in their keys and encrypt the data on my platform using their keys. And that's one of our critical requirements as well. Now, what we did a couple of years back, which was our most ambitious move, is we obviously, when we started building our entire tech stack, we started off with a lot of individual applications, one for managing supply chain finance, one for securitization, one for loans, and so on. But over a period of time, we really wanted to consolidate. And this is what we came up with. We call this the banking operating system. And this is already live. It's serving many customers today. But very simply put, without going too much into detail, it's a microservices, sitting on microservices. It's a multi-layered microservices architecture. And we have databases all over the place, right? We have databases right at the foundational layer. We have databases at the business capabilities layer. And the resiliency and the criticality of this data cannot be understated, right? It's extremely critical across the board. This entire layer has been built to be extremely highly durable, and reentrancy is across the stack. That's very critical. Now, what this leads to is the data plane over here right at the bottom and on the side is extremely critical to our requirements, and that's kind of what prompted us to really look at a new database. Why did we look for a new database? One thing that every customer on that slide that I shared before wants is they want the highest reliability, they want the best performance, and they want it at the lowest cost. And that basic formula is not going to change for the next 20 or 100 years, right? That's going to stay. So our database costs were rising, and the need for performance was also rising every day. We needed to support ability for customers to encrypt their own data using their own keys, And that was not possible with traditional databases because we had to kind of shard them. Physical isolation was really turning out to be a problem. And we had to scale the data layer by orders of magnitude. Some of the requirements of the new database is we had to support our cloud-neutral architecture. I did not want a database that works beautifully on the cloud but does not work on-prem, or works only on AWS but does not work on GCP. I could not, we could not live with a database like that. It had to obviously be 100% ACID compliant. We needed auto-sharding with zero manual intervention. Because the scale at what we are operating at, it becomes impossible for us to really put people on the job. One of the key aspects that I'd like to call out here is this entire technology and operation is being managed by a very lean team sitting here in Bangalore and in Chennai, and a very small team in Hyderabad. Our DevOps team right now is about 5 people. So we really can't have, we can't afford to have a large team of people monitoring databases, servers, and our entire infrastructure. It needs to be very autonomous in every sense of the word. Monitoring and observability, that goes without saying. I needed support for OpenTelemetry, CloudWatch, or any equivalent. And extremely high throughput. We wanted to support 10K QPS or higher over a sustained period of time. Now, to cut the long story short, we came across CockroachDB. Our chief architect had worked with CockroachDB in the past, and that's how he kind of introduced me to this idea and said, hey, you need to look at CockroachDB. And we went through the entire process of doing a POC, we did experiments, we did a whole battery of tests, and this is what we came up with. This is not really so much about challenges that we faced, but fundamentally, maybe just a description of what we went through to kind of get here. One of the things we had to do was change the isolation levels. That's something that we learned along the way. Whether we are looking at read committed or serializable was fundamentally a decision that we had to make on whether the workload would be able to handle dirty reads or whether it needed a high level of concurrency. That took a little while for us to really identify. We use Liquibase a lot for our migration. We realized that Liquibase also ends up creating some internal tables for managing its work, and that is not supported by Mold. So we had to do a one-time creation of those tables. So that's something that we could probably look at supporting, hopefully in the future. That would be great. And for a lot of our team members who had worked with traditional databases, I mean, non-distributed databases, could be Oracle, could be Postgres, and so on, there's a little bit of a learning curve for them. Not very difficult. It took a couple of weeks for them to really, and your training certainly helped, for them to understand the fundamental concepts of what a distributed database is like, how it functions, and so on. Server-side correction pooling is a must. That's, again, something that we learned as a part of our entire POC phase. And what did we see? We certainly saw a significant cost advantage. The elasticity that CockroachDB was able to offer us for some of our workloads, particularly on the collection side. By RBI regulation, we are not allowed to contact customers beyond a certain time in the day, which means my systems are sitting idle from, let's say, 9 p.m. onwards. So why spend money on a database? Why over-provision that? And that's where CockroachDB really gave us benefits of cost. Mold tool has been certainly fantastic. It's taken the pain away from migrating from Postgres to CockroachDB. It's been really easy for us. And almost all Postgres features are supported. So we didn't really have to put in a lot of development effort to kind of re-engineer our applications to work on CockroachDB. And that's been a big blessing for us as well. We use temporal heavily for our durable workflows. And we were storing a lot of states on temporal. And by leveraging CockroachDB, we were able to really significantly bring down our cost of temporal. That was a big plus for us. And lastly, obviously, we were able to manage campaigns. I just spoke about the 1 billion interactions that we do in a month. We were able to do that at a much lower cost without any disruption. So this has fundamentally been what we have done. I know it's a short talk, but thank you so much for having me. Me and my team are here. If anyone wants to understand a little bit more about what we do at Yubi and how we've been able to leverage CockroachDB and what our plan is for the next couple of years in leveraging more of CockroachDB, I'll be more than happy to talk to all of you. Thank you so much.